Okay. Good morning. My name is Miguel Bernal Marin. I'm working for Intel in Guadalajara, Mexico. Also, I'm a lecturer university in these two universities in Guadalajara. This time I will show you how can we use 3D sensing in embedded systems. The agenda will be, we will see a little bit of overview of 3D sensing, what is the Intel RealSense technology, why we are using Minnowboard Max, and what is RealSense and where a lot of other words can we use it there. First of all, the 3D sensing, to get a picture or to get an object, a real object inside digitalized, we need a camera. But this camera should, we need to get their parameters to get the fixed structure inside. But as we are living people, we need 2 cameras at least to get the 3D position of each point. So the literature asks to have two cameras to get the depth of a point, and then we will get this object digitalized in our virtual world. There is a lot of techniques to have to digitalize a 3D object, and one of them is a disparity image between the 2 images. We will find the difference between the pixels, and we try to find the depth of each of them. These techniques were used in the schools and in technology, but in 2010, Microsoft introduced RealSense. This RealSense, it was a new technology. The Kinect, it was introduced by PrimeSense. It was a company that Microsoft paid to develop the Kinect from Xbox. This camera has a projector that is projecting a dotted grid, and it has an ER camera that sees these dots and calculate the depth of it. And we have here a RGB camera. So we can get the 3D from using colors and the depth. But we have one inconvenience here. The Kinect is a little bit big for embedded system or to do portable applications. So if I would like to use a helmet with that to help blind people, I need to put this Kinect in a helmet, but it is big. And also I should have a big computer. But what about drones? Also the Kinect is too big for it. We have restrictions regarding the way that the drones can fly. So here's where Intel comes. It researched and developed a new technology called RealSense. Right now it has 2 products, RealSense for short range and long range. We call it the front camera and the rear camera. And with this, as you can see, it is inside a laptop, so the size it is reduced. This camera, the front camera, it is similar to the Kinect. It has RGB camera. It has a IR laser. It has IR camera, and this use the same feature as the Kinect uses, but in a small size. The rear camera, there is a little bit difference. We have 2 ER cameras, one the left and one the right. So this brings a new features to get 3D point clouds, and we have the RGB camera also, the color camera. So we can get a much better image disparity, and then we will have a better 3D representation of the objects. This camera also could be used in outdoors. As you know, the Kinect has one lag. If we put the Kinect outside, the IR from the sunlight, it's oversaturate the sensor. With this model, we have a stereo camera, IR camera, so we can modify the parameters of the camera to try to get this disparity. And also we have the RGB camera, and this helps us to get the 3D representation of the object outside. The specification of the camera are here. As I can say, with previous, there is two from rear and front. There is a third generation right now. That is SR300. But we are focused right now in this one, that it could be used in outdoors. As I mentioned before, well, the R2000 has active stereo IR, and it could be used in outdoors, and well, as I tell you, the size is matter. We have right now a small device, but this device have one restriction, one constraint. It communicates using a USB 3 protocol. So if we would like to try to bring this to embedded, we need a board that it supports the USB 3. So that's why comes the Minnowboard. The Minnowboard has a USB 3 port. So right now we have a camera, and we have a small board that could be used in drones or in embedded systems. As I told you before, the size matters. As you can see, the size is relatively small, and it could be used in any embedded and drones or IoT devices. But what about the Linux space? Intel, when developed the RealSense technology, he said, I won't develop a library for Linux. So some guys start to develop this library, Deep RealSense, that it's a cross-platform. It is for Linux, OS X, and Windows. It is enabled in these three types of cameras, and it is only for the capture functionality of these cameras. There is a RealSense SDK that is provided by Intel for using Windows, that it provides some vision algorithms. This library is only for the camera, to get the cameras. And they developed this library for researchers, creative coders, app developers in the areas for virtual reality, robotics, Internet of Things. The main or the principal developers are Dimitri Diakopoulos and Sterling Austin. They were developing this library, And it's worth to mention that this library is not an official Intel product. It is an open source project. I meant to bring the functionality of these devices. And also, it doesn't have any relation with the Intel RealSense SDK. Also, there is some, in the Intel software, there is some software to update the firmware from the camera. This library won't do that. This library is focused on getting the images or getting the data from the camera, and so you can process later. As I mentioned before, it is for the 3 devices, the 2nd generation and the 3rd. The compatible platforms that are right now that is used by this library is Windows 8.1, Ubuntu 40, and macOS 10.7. But also, this library could be ported in another platforms. It is developed in the standard of C++11, and the main or the core library is exposed via C89 ABI, and there is a single header file in C++ that is wrapped all this library and brings some extra functionality to the C core. For those who were playing with the Kinect, there was an open NI library that was also developed in C, and there were a wrapper. This also has the C, the main core, and has the C++ wrapper. The library brings some functionality. This brings the streams from the depth, the color, and the infrared. Also, it brings the rectified images and depth aligned to the color. We will see some pictures in the next slide. It will bring us the intrinsic and extrinsic information from the camera. And, well, it is exposed by the USB video controller API. And this library could be used with several cameras attached on the same device. How it works? Well, you need a kernel patch. It's worth to mention that this kernel patch it will be better in the 4 version of the Linux kernel, 4.4 at least, because some UBC libraries is not compatible with 3.18 kernel version. So to get this functionality, it's better to have a recent kernel there. And is using all the Video for Linux 2 libraries and the USB video class. This library is integrated with some operating systems like ROS, Robotic Operating System. It is integrated in Yocto and also in Arch Linux, and will be integrated in Clear Linux project also in the near future. Well, here is an example of a screen. As you can see, here is the RGB images. Here is the depth map, and here are the 2 IR cameras. And as you can see, there is it looks like a noisy image, but you are viewing the dot that is projected by the camera. And well, With this, you can do a 3D cloud point. So you are matching the RGB image with the points that were captured, and you will have a 3D cloud. And it is extremely easy to do some research with this. What about drones? Normally, drones are used camera to recognize the environment, and there we have here on a 6-rotor drone, which is using a GoPro 4. As I told you, the size is mirror, so the GoPro 4 is small. Here we integrated a small board that communicates to the GoPro 4 and do some flights. Well, instead of using a GoPro 4, we installed the RealSense camera. We added the Minnowboard, and well, we do some flights in it. And well, the weight of this camera is extremely slow, so any drone can handle it. Other boards that are enabled in this library is Intel Computer Stick, Kangaroo, and the Upboard. This is why they are using the super speed USB, the USB 3. Well, a clear commercial. If you want to get one, there is available here in this page. So you can get this one that is the R2200, and you can buy one and do some research with that. Also, I would like to thank to some students that helped me in the research. And well, that's all I bring you. I don't know if you have some questions. Thank you. Yep.
What's the kernel patch for? The kernel patch that's needed to have the RealSense work?
Sorry?
What is the kernel patch that's needed to make the RealSense work? You said there was a kernel patch to apply.
Yeah, the kernel patch, it is integrated in the UVC module. The kernel patch is added a new type of images, like the sensor, the cloud point, and the ER images. So to get these images, the kernel is patched with this new type of images that it will get from it.
Okay, thanks. I have another question. What is the CPU used on the RealSense board?
In the Minnowboard
No,
is
the RealSense.
RealSense?
Yeah.
Again?
Yeah, there's probably some kind of. Yeah, it's an ASIC.
Yes, it's
dedicated ASIC. That's you.
Okay, I also have a quick follow-up question. I know that initially it was kind of hard to get the RealSense working on ARM, but I presume that what you presented now resolves this.
It could be, yes, because it's a driver independent. So if you have a board with USB 3, maybe you can use it. I didn't try it, but the theory is that.
Okay. More questions?
What is the depth of field? 1 meter, 2 meters?
The depth of field of the It is theoretically 10 meters and outside, and in indoors 3 meters. This is because it's a small camera, and in indoors we will use the dot matrix, and the outdoors it will do the disparity with the cameras.
What can you tell us about upcoming outdoor models?
Of what? Sorry?
Of like follow-ups to the R200. I'm sure Intel has a product pipeline.
I don't know exactly.
Yeah, but no, it's good. Like from the responses in the audience, I know now who to talk to.
Again, I didn't get it.
Maybe I didn't understand, but the kernel patches, are they being integrated, mainline? Are there an effort for mainlining them?
I need to contact to the developer from the RealSense. Maybe they will integrate it.
Nice.
It is a small, really. It's more, yes, because you need to.
You said that in outdoors you need to calibrate or calibrate the sensors because otherwise you have problem with the exposure. How do you do that?
In the library there is some functions that you can calibrate. You can move the exposures on the IR. Also, you can get the iris on the camera, so that it cannot oversaturate them, and that is integrated in the RealSense.
Okay.
More question? Okay.
What is the UVC model?
The UVC is the USB class video for inside the kernel. It's a dependence from the video for Linux. It's a class in the kernel that is exposure all the functionality from the video using a USB.
Okay, thank you.
Just one more thing. In Clear Linux, in the Linux embedded kernel, it's already integrated, the patch, in 4.1. And if anyone wants to the patch for previous version, I have the patch since 3.18, I think.
Okay, great. So thank you for attending.